You are welcome to my class today. The very last topic we treated in our second term scheme was trigonometry involving compound angles. That was the last topic we treated before we went on holiday. But today, let's set the stage for a proper beginning this third term as we state our learning objectives. At the end of this lesson, students will be able to state the meaning of permutation. And secondly, we'll be able to use permutations in solving problems. Now let's quickly understand what permutation is. Permutation. Permutation is connected with arrangements of a set of objects. That's permutation. So meaning that in permutation, order is very, very important. That's why you see this order here. Order of the object we are arranging is very important. ABC is not the same thing with BAC. That's for permutation. So what we are arranging has importance of what? Order. Order is very important when we talk about permutation. Now I have an example here on the screen. We have we are asked to arrange three letters ABC. How many ways can this be done? Now as you can see on the screen there, we have ABC, we have BAC under it, then we have CAB, ACB, BCA, then CBA. Those are the various different arrangements. So we have 6 distinct arrangements for these objects. We're starting manually like this so that we understand that what we are dealing with is arrangement of objects. For this particular question, the object we are talking about is what? Letters A, B, C. Okay, we can actually form it. If I have ABC first arrangement, I can begin with the same A and decide to interchange B and C, ACB. Then I come to B. If I begin with B, I can have AC. And if I begin with B again, I can interchange the positions of C and A. Then if I begin with a C, I can have A, B. Then if I also begin with a C, I can as well have B, A. This is what permutation is all about. So if we count the number of arrangements we have, 1, 2, 3, 4, 5, 6. So the answer is 6. That's why we have the total number of ways we can have that is 6. 6 arrangements. Okay, good. Let's look at our next slide. Arranging n objects. The n could refer to any number. Arranging n objects. Remember, for permutation, the order of the object we are arranging is very, very important. Now, we're going to be making use of a very important concept here that we call factorial. You see, n factorial, we call this symbol. This symbol, we call it what? Factorial. We call it factorial. Okay, now so if I have any factorial, n factorial, look at the formula there. You multiply from that number, that particular number given, down to 1. For example, if I have 5 factorial, my 5 factorial will be 5. You start from 5 times 4 times 3 times 2 times 1. Good. So any number given, you start from that number and multiply down to 1. Good. That's what factorial is. We're going to be making use of factorial in this our permutation. Now let's look at what this theorem 1 is talking about, arranging n objects. In general, n objects can be arranged in n number of ways. For example, if I ask you to arrange 10 objects, it's simply 10 factorial. So the example 2 here is talking about, as this example 2, that's our focus now. In how many ways can 4 different resistors be arranged in series? Okay, obviously that will just give us 4 factorial. And what does 4 factorial means? 4 factorial, that you see, you have 4 times 3 times 2 times 1. So multiplying that, the answer gives us 24. Good. That is that particular one. So if I ask to multiply to arrange any number of objects, you use the factorial. If I ask you to arrange 7 objects now, okay, in how many ways can it be arranged? 7 objects, you just tell me 7 factorial. Good. Now let's proceed to the next slide. Number of permutations. The theorem 2 is talking about number of permutations. The number of permutations of n distinct objects taking r at a time, meaning that n represents the total number of objects that we want to arrange. R is probably between the difference between this particular one and the first example we took, or the last example we took, is that for this case, we don't intend to arrange all n objects. We want to arrange r at a time. We want to take r out of the n to arrange. Okay, and we could write, you see the symbol the notation we are using here, notation that you have seen here, nr. Can also write it as like this, n permutation r. Okay, some textbook will still use this n r. They are all saying the same thing, so we can use anyone we like to represent our permutation. Okay, now look at this. The formula for our permutation is simply what I have here. It will be n factorial over n minus r factorial. Just find the difference between your n and r. Okay, n factorial over n minus r factorial. That's a simple formula for factorial. Okay, so if I have n permutation r is simply n factorial, this is the n, that's the total number of objects we want to arrange, all over n minus r factorial. That's the difference between the two. Okay, and that's what you have in the formula. Take note that 0 factorial is equal to 1. That's it. 0 factorial is equal to what? 1. Now let's forge ahead and see what we have in our next example. Okay, let's look at this next example. In how many ways can a supermarket manager display 5 brands of cereals in 3 spaces on a shelf? In 3 spaces on a shelf, we want to display 5 brands of cereals in 3 spaces. Okay, that means that's talking about the permutation we are talking about is going to be, we are using 5 permutation 3. We can still write it like this. That's 5 3. All of them are valid and correct. Okay, so that's the total number of objects we want to arrange, and we only have options of 3 spaces. That's 5 permutation 3. Remember the formula, n factorial over n minus r factorial. In this case, our r is 3, and my n is what? 5. Okay, so that's 5 factorial over 5 minus 3 factorial. So 5 minus 3 factorial will give us 2 factorial. So if you simplify your factorials, what you have, if you simplify what you have over there, now my 5 factorial simply means 5 times 4 times 3. I can say 2 factorial because I know that what I have at the denominator here is also 2 factorial. I'm trying to show you breaking this down now. So my 2 factorial cancels 2 factorial. So I have 5 times 4 times 3. So that gives me my answer as what? 60. So we have 60 ways in which we can arrange the 5 brands of series in 3 places. Good. Now let's move ahead. The next example. How many different number plates for cars can be made if each number plate contains 4 of the digits 0 to 9 followed by a letter A to Z? The first question says no repetition of digits is allowed. We're on this particular question now. No repetition of digits is allowed. Repetition of digits is allowed. That's the B question. Now, there are 10 possible ways. So if you have from a 0 to 9, that's 10 digits. A 0 to 9 gives us how many digits? 10 digits. 0, if you count 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That we have 10 digits. So we need to take them 4 at a time. We need to take them how? 4 at a time. Okay. Look at. Remember, it says if the number of plate contains 4 of the digits 0 to 9. So we have 10 digits to arrange, and we need to pick 4 out of the 10. So that's talking about 10 permutation 4. That's why we have this particular one here. Okay, now times 26. Our letter A to Z, if you count them, we have there are 26 in numbers. So if we simplify 10 permutation 4, we have 10 factorial over 10 minus 4 times 26, because we are to add letter from A to Z to it, just a letter followed by a letter from A to Z. So we multiply that by 26. So if I simplify that, 10 factorial over 6 factorial times 26 gives us this particular answer. Good. We can all do that now. If I say my 10 factorial, I will continue to, if I multiply 10 times 9 times 8 times 7 times 6 times 5, okay, times 4 up to 1 over 6 factorial. Simplify, just punch your calculator, that gives you your answer. Then the B part says with repetition we have simply number of digits from 00 to 999. Okay, if we have 4 digits, we want to arrange 4 digits. That means from 0 to 999. Okay, that's 000 to 999. That since repetition of digits is allowed, because in between 00 to 999 we could have 4444, 1111, 1122. So we can have repetitions of those particular digits. So we use this method from 00 to 9999. Okay, that would be 10,000 what digits. So that's 10,000 times 26. You see that this is quite higher because repetition of digits is allowed. So if no repetition of digits is allowed, we take this approach. Repetition of digits allowed, we take this approach for our B. Okay. Let's note our questions, and don't forget to, you can post your questions, okay, online. Under each page you have where you can make comments. Okay, let's forge ahead in this class today. This particular aspect is talking about permutation of different kinds of objects. The number of different permutations of n objects, which n1 are of one kind, are of second kind, nk are of a kth kind, is. Now what this place is talking about is when we have indistinguishable objects. Indistinguishable objects that cannot be distinguished. They look alike. We cannot tell the difference between the objects. Okay. if we have that case, we are having n factorial over, there is a number that cannot be distinguished, n1. The second one, this n2, cannot be distinguished, n3 cannot be distinguished, up to the last one. Now we quickly see that by looking at this second example. Let's look at what we have to do there. Example 5. In how many ways can the 6 letters of the word mammal be arranged in a row? Now this example will explain to us very well what this formula is all about. Good. Just watch. It's very simple. Just watch what I want to do now. In how many ways can the 6 letters of the word mammal? So we are looking at mammal. How many letters do we have in mammal? Let's count. Mammal. Mammal. How many? Let's count. 1, 2, 3, 4, 5, 6. That means we have six objects there, 6 letters. Okay, since we have 6 letters, we're going to obtain our permutation as this 3 factorial. And if you notice, m appears how many times? Let's look at this first letter. M appears 1, 2, 3, because the m's, they are all the same. You can't distinguish them. They are of one kind. That's the one kind they are talking about in the formula above. They are the same. You can't distinguish between the m. So when you have the same object like that cannot be distinguished, so I will divide by that 3 factorial because my m appears 3 times. Times which other letter can I have 2 times? Which other one? I have a. A appears 2 times. That is 1. And the other a, 2. So I'll also divide by 2 factorial. Okay. Then the other one, there's no point putting the this 1 factorial may not necessarily be put because the L only appear once. That's why they multiply by 1 factorial. Of course, 1 factorial, we know that that one will give us 1. So we don't necessarily have to put it. But if you want, like this, you can put the 1 factorial because this L appear once. Okay, good. So if we simplify this, 3 factorial will give us 3 times 2 times 1. 2 factorial, 2 times 1. The 6 factorial, of course, you already know, that will give us 6 times 5 times 4 times 3 times 2 times 1. Just simplify and cancel out. Our final answer gives us this. Okay, so we now understand how to find the permutation of objects that cannot be distinguished. Objects that cannot be distinguished. Good. And that's what they are trying to say here. So if you check your textbook, your new further mathematics project, okay, for your book 2, you will see it as indistinguishable objects. Good. Now let's move ahead. This is talking about arranging objects in a circle. The simple formula is when you want to arrange an object in circular form like this. Objects round a circle like this. The formula is simply n minus 1 factorial. Just take that formula that way. Now look at the formula, this example 6. In how many ways can 5 people be arranged in a circle? Simple. Putting your formula 5 minus 1, the n that we have there is 5. We have 5 people. 5 minus 1 factorial, that's 4 factorial. And 4 factorial, we know will give us 4 factorial is 4 times 3 times 2 times 1. So that's how we have this answer as 24 ways. Okay, so we've done that about arranging objects in a circle. Good. Let's move to the last slide to quickly summarize what we have done today. Now we have made some points today. We define, or we have explained what permutation is the arrangement of objects. Okay, arrangement of objects taking into account their different orders. Orders are very important. That's why I said ABC is not the same thing with BAC. We have the same objects within the arrangement, but they don't follow the same order. So order is very, very important when we are talking about permutations. So if I write 1, 2, 3, it's not the same thing with 2, 1, 3. It's not the same thing with 3, 1, 2. So order is very important. Put that at the back of your mind. Then we also have this. The second one, the number of different arrangement of n objects is n factorial. If you are just talking about, we want to arrange all the objects they are talking about, all of them. We want to arrange them. We have n factorial. Okay, n factorial. And we talked about our simple formula for permutation. If we want to arrange objects and we don't intend to arrange all the objects at the same time, we want to pick maybe from 9 objects, I want to arrange 3 of it. So that will give me 9 permutation 3. Okay, don't forget that. I want to arrange, let me give you an example, and as I round up, I want to arrange 10 objects. I want to arrange 10 objects, and I'm to arrange 4 out of the 10. I want to arrange 10 out of the 4. That gives me 10 permutation 4. So this is as against the n factorial we have here. This one is when you want to arrange all the 10. That will give me 10 factorial. 10 factorial. I'm just trying to throw more light. Okay. So our answer for the formula for permutation is simply what you see there, which we have applied. Thank you for listening, for your rapt attention. There's a quiz connected to this class today. Please make sure you attempt the quiz. Attempt the quiz so that you test your understanding of what you have learned in this class today. Thank you very much. Till we meet next class.